If life should be everywhere, then why does the universe seem so silent? If we scan millions of stars and see no unmistakable signs of life, why hasn't one signal, one unmistakably alien trace, shown up on our instruments? We know this. The cosmos contains billions of galaxies with countless planets, yet nothing definitive stands out. But this silence doesn't neatly fit our expectations. It raises a profound tension in our quest. If life is common, why does evidence continue to evade us? What we know, with real confidence, is actually very modest, though it may not feel that way at first. We know that stars are not rare. They fill the galaxy by the hundreds of billions, and many of them are not alone. Around countless stars, planets quietly circle, locked into rhythms that have lasted for billions of years. From our vantage point on Earth, we have already identified thousands of these worlds, distant exoplanets, revealed through faint shadows, subtle wobbles, and tiny changes in starlight. Among them are planets that orbit within what we call the habitable zone. Not because we know life exists there, but because liquid water could exist under the right conditions. It is a narrow definition, born from what life looks like here, and nowhere else. We also know that humanity has reached beyond the boundaries of its home system. Our spacecraft now drift through interstellar space, carrying messages, instruments, and the quiet ambition to listen. We scan the sky for signals, patterns, and anomalies, anything that might suggest we are not alone. And yet, for all of this achievement, for all this data, what we truly possess is still only a sketch, a rough outline, a map with far more blank space than detail. What we know is remarkable, but it is also incomplete, and it barely touches the deeper mystery of life beyond Earth. Based on the sheer scale of the universe, our expectation feels almost unavoidable. With hundreds of billions of galaxies, each containing hundreds of billions of stars, it seems statistically reasonable, even inevitable, that life should exist beyond Earth. And yet, when we look outward, the evidence refuses to cooperate. We see no clear biosignatures that cannot be explained away by geology or chemistry. We detect no confirmed technosignatures, no engineered signals, no unmistakable traces of advanced technology. There has been no moment of contact, no signal so clear that doubt disappears. The sky remains quiet. This tension has a name. Astronomers call it the Fermi Paradox. The simple, unsettling question, where is everybody? End quote. Where is everybody? If life is common, and if intelligence arises naturally, then the silence itself becomes the anomaly. What makes this contradiction even more uncomfortable is how close it exists to home. Even on Mars, the most accessible planet beyond Earth, studied for decades with orbiters, landers, and rovers, we cannot prove that life does not exist. We can examine surface conditions with remarkable precision, analyze soil chemistry, map radiation levels, and study ancient riverbeds. But life does not need the surface. It can hide underground, shielded from radiation, locked beneath layers of rock and time. And because science cannot prove a negative, even Mars remains unresolved. So the contradiction deepens. The universe feels full, but the evidence feels empty. And even our nearest celestial neighbor refuses to give us a clear answer. One possibility is both simple and deeply unsettling. Life may already exist beyond Earth, but it does not resemble anything we have learned to call alive. Our search is shaped by familiarity. We look for water, oxygen, carbon, the chemical fingerprints of life as it emerged here. We search for atmospheres that breathe like ours, temperatures that feel comfortable to us, worlds that mirror Earth closely enough to feel reassuring. In doing so, we quietly assume that life everywhere must follow the same path we did. But that assumption may be our greatest limitation. Life elsewhere could be built on unfamiliar chemistry, powered by energy sources we barely understand, structured in ways that leave no obvious trace in starlight or planetary spectra. It may not alter its environment dramatically. It may not release gases that announce its presence across light years. It may exist slowly, subtly, or briefly, leaving behind no signature that our instruments are trained to recognize. In that case, the universe would not be empty at all. It would simply be unreadable. We may be searching for reflections of ourselves, when what exists is something fundamentally other. And if that is true, then the failure is not the absence of life, but the narrowness of our expectations. What we expect to see may not be what is actually out there. Another possibility is less comforting, but perhaps more realistic. The universe may be quiet, not because we have failed to listen, but because there is very little to hear. Advanced civilizations may be genuinely rare. Simple life, even if it arises, may not leave detectable traces across interstellar distances. And intelligence technology, communication, expansion may be an even narrower outcome. The famous Drake equation tries to capture this uncertainty by multiplying a long chain of probabilities. Stars with planets, planets that are habitable, life that begins, intelligence that emerges, civilizations that choose to communicate. Each factor narrows the funnel, and if even one of those steps is uncommon, if life rarely begins, if intelligence rarely evolves, if technology is short-lived, the final number collapses towards zero. Not dramatically, quietly, mathematically. This leads to a paradoxical conclusion. The universe may not be empty, but it may be sparsely populated with civilizations that appear briefly, flare for a moment, and then disappear. A technological society could rise, alter its planet, transmit for a few thousand years and vanish, leaving no lasting signal behind. On cosmic timescales, that is not endurance. It is a blink. If this is true, then silence is not surprising at all. It is simply what a universe filled with rare, fragile intelligence would sound like. And the quiet we observe may not be evidence of absence, but a reflection of how fleeting civilizations truly are. A third possibility challenges not the universe, but ourselves. Perhaps the problem is not that no one is speaking, but that we are listening for the wrong kinds of voices. For decades, our search for intelligence beyond Earth has focused on what feels familiar. We listen for radio signals. We watch for flashes of light. We assume that advanced civilizations, like us, would choose to broadcast their presence using electromagnetic waves across space. But that assumption may be profoundly limited. Alien technology may not communicate through radio at all. It could leave signatures in forms we rarely consider subtle distortions in space-time, artificial patterns embedded in gravitational waves, or vast engineered structures that reshape the light of entire star systems. Intelligence may announce itself not by speaking, but by altering its environment in ways that nature alone cannot easily explain. It could even reveal itself chemically. Industrial activity might leave long-lived pollutants in a planet's atmosphere, traces that persist long after a civilization has stopped transmitting or even ceased to exist. If intelligence expresses itself through such indirect means, then silence becomes misleading. The signals may be present, layered into the data, hidden within phenomena we have not yet learned to interpret correctly. In that case, the universe has not ignored us. We simply have not tuned our instruments or our expectations to the right cosmic channels. And the moment we do, everything we thought we knew could change. So what, exactly, would end the debate? What kind of discovery would move alien life from speculation to certainty? One possibility would come from chemistry, but not just a single clue. If we were to detect multiple biosignatures within the same planetary system, the case would become far stronger. For example, the simultaneous presence of oxygen and methane in a distant exoplanet's atmosphere, locked in chemical imbalance, would be extremely difficult to explain through non-biological processes alone. Such a combination would suggest an active system constantly replenishing those gases, a quiet but powerful hint of life at work. Another path would be technological. Certain signals cannot be mistaken for nature. Structured laser pulses, highly ordered radio patterns, or repeating signals with mathematical precision would point unmistakably toward intelligence. Even more compelling would be large-scale engineered structures, vast constructions that alter starlight itself, leaving fingerprints that no natural process could easily imitate. A third possibility reaches deeper into time. The discovery of ancient relics or artifacts, Whether a megastructure orbiting a distant star or a deliberate marker hidden within our own solar system, would carry extraordinary weight. Such a find would not require communication. Its mere existence would be the message. None of these ideas belong to science fiction alone. They are serious, active lines of inquiry discussed by scientists today, careful, methodical attempts to identify evidence that could not be explained away. And if even one of these observations were confirmed, the question of whether we are alone would finally have an answer. For now, the cosmos keeps its deepest secret, just beyond our reach. We see hints, faint signals, ambiguous data, possibilities that almost resolve into answers but never quite cross the line into certainty. Each discovery seems to promise clarity, only to dissolve into new questions the moment we look closer. Yet, this silence may not be emptiness at all. It may be a canvas, a vast, unfinished space, inviting patience, imagination, and humility. The universe may be asking us not simply to wait for answers, but to refine how we search, to look deeper, to listen more carefully, and to expand our understanding of what life could truly be. And so we continue. With every telescope brought online, with every mission launched into darkness, with every signal scanned, filtered, and questioned. Not because we expect an easy answer, but because the question itself defines us. Across history, no species has ever asked something so large, so personal, and so humbling at the same time. Are we alone? For now, the universe does not answer. And perhaps that silence is not a refusal, but an invitation. If questions like this linger in your thoughts, then keep looking upward and inward with us. The universe is not just a vast collection of stars and planets. It is an invitation to wonder, to slow down, and to confront questions that have no immediate answers. In a world that moves quickly and demands certainty, cosmic questions ask something different of us. They ask for patience, for humility, for the willingness to sit with mystery rather than rush to conclusions. And sometimes, the most meaningful insights do not arrive when the universe speaks loudly, but when we learn to listen more carefully to patterns, to silence, to what remains unexplained. This search is not only about distant worlds or distant civilizations. It is also about perspective, about understanding our place in something far larger than ourselves, and recognizing how rare and fragile consciousness may be. Because in the end, we do not search for others only to find life elsewhere. We search to better understand who we are reflected in the vast, echoing mystery of space.